Okay, this is lecture 15. And I'm going to do example 19.5, page 672. In this example, you have two parallel plates. These plates, they're parallel, and one is positive, one is negative. The distance between them is 4 centimeters. The distance between them is 4 centimeters. So D is equal to 4 centimeters. And a charge with electronic charge, E, gain, it gets 2.5 kilo electron volt of energy. So the energy it gets from going from this point to this point is 2.5 kilo electron volt. Okay? So the question is, A, what is the electric field E between the plates? What is E? And B, they want to know if there is a charge Q is equal to 0.5 microcoulomb, what would be the force on that charged particle? Okay, so that's a question. All right, so in order to do that, first let me write down the formula for electric field E. So E is equal to, the one that's relevant for us is VAB by D. And remember, VAB is a positive quantity, that VA, the potential of plate A minus potential at plate B. All right? And now, the particle has charge 1 unit of electronic charge. That is E, that is 1.6 times 10 to the power minus 19 coulomb charge, right? And by definition, when you move a charge of this between these plates, right, and the voltage difference is 1 volt, then if the two plates have voltage difference 1 volt, and if you move a charge of E, which is 1.6 times 10 to the minus 19 coulomb, then the energy it gets is 1 electron volt. That's the definition of 1 electron volt. So now we get 2.5 kilo electron volt. That means the voltage difference between these plates must be 2.5 kilovolt. All right? So let me explain again. If the two plates, the voltage difference is 1 volt, and you move a positive charge, Q, which is equal to electronic charge, then the energy it gets once it gets to this plate, the energy it gains is 1 electron volt. So now the energy it gains in this problem is 2.5 kilo electron volt. That means the voltage difference must be 2.5 kilovolt. So VAB is 2.5 kilovolt. 2.5 kilo means 10 to the power 3 volt. Divided by distance, which is 4 centimeters, 4 times 10 to the power 2 meters. Negative 2 meters. Okay? So the answer is 6.25 times 10 to the power 5 volt per meter. And you should know that volt per meter is the same as newtons per coulomb, because that's the unit for electric field. 6.25 times 10 to the power 5 newtons per coulomb. And the reason I changed the unit, as you will see in a second, in part B, we want to know the force on the charge 0.5 microcoulomb, and force is equal to Q times E, and Q is 0.5 micro means 10 to the power negative 6 coulomb, and the electric field E is the one that we just found, 6.25 times 10 to the power 5 newtons per coulomb. So coulomb cancel. The answer is in newtons, and the answer is 0.313 newtons. All right. The only thing that might be complicated for you is why we get this voltage difference VAB as 2.5 kilovolt. That's the only thing. So just to make sure you understand, I'll explain it again. And if you get it already, you can quit. You don't have to listen anymore. Let's suppose there are two plates and the voltage difference is 1 volt. And if you have an electronic charge that is one charge that is equal to the amount of an electron has, but this one is positive charge, then when this electron moves from rest to this plate, then it will have some velocity, then it will have some energy. The energy it gets at this point is 1 electron volt, because this is one electronic charge object moved from here to here, and the voltage difference is 1 volt, and we call that energy 1 electron volt. Now in our case, the energy it gets is 25 kilo electron volt, but the charge is still the same, E, electronic charge, so that means the voltage must be 2.5 kilovolt. All right.